next line here that I should have read out. Kingdom. The next one after that. Perfect. What's after phylum? What? I've got class. I know I do. What's after that? I've also got order too. Sin. Family. Kind of. Keep going. I'm a genius. I got it. And I am a member of a species. I am one of... It's genus, but I said genius. Because I was playing a game. A really bad one, but nevertheless. Very general, very specific. So if I said I'm thinking of something in the domain eukarya, I could be thinking about a number of items. But if I said I'm thinking about Homo sapiens, well then that's exactly one item. Do you understand this principle? Is there anything else about taxonomy? Yep. The three domains are eukarya, archaea, and prokarya, right? Come on, guys, it's chapter 1 stuff. We got this. Eubacteria. I've got that song Slim Shady in my head right now. What else do we have? What else do you want to go through? Do you want to go through the kingdoms real quick? Is that cool? You got this? How many kingdoms? There's like 32 now, but we use still the old 6 kingdom system, right? So I'm going to start off with the oldest kingdom, which is going to be your Eubacteria, and then I'm going to go on to the next, the more newer one, Archaeobacteria. Y'all fine with that? Cool. What's next after that? Okay, I'll take this, Protista. That's right. Actually, well, see, that's the thing is, yeah, you're correct. Yeah. Old school style. Yeah. Let's see. After that's going to be the fungi, then the plantae, and then the animals. Cool? I think we know about each of those. I don't think there's a problem with this. You know, we really went through and tried to get like the facts about each one of these down very, very, very like concrete, I think. You know, we did look at the animals and, you know, we broke these down into a slew of different phylum, or phyla, starting out with your Porifera, and then going to your Cnidarians. After that was the Platyhelminthes. And I always get I will get this. I'll get a little off in the order here, and that's just I apologize. But I'm pretty sure the next one is going to be the annelids. Then it's the mollusca. Then the arthropods. Then the echinoderms. And lastly the chordates. Now again, that's not a final, you know, number of things. That's a pretty good estimate. Cool? Alright, that's not every phylum, that's just a lot of the phylum. Cool? Annelida. Sure. Which one of these is dorsoventrally flattened and has bilateral symmetry? Platyhelminthes is the answer. How do you know that? Flatworm. That's the giveaway. Which one of these creatures is comprised of multiple fused rings? He's right. Fused rings. Like you see, Albert, can you name me a creature that is flatworm? Can you name me one worm that is flatworm? No. But what he's done... Apply down the piece. Okay, tapeworm. What he's done is he's associated like a tapeworm to work lighting helminthes. It's look, and therefore that's the idea of flat. And that's essentially the extensiveness that I kind of covered it, basically. You know that, you got that question made. We good? You want another question? Which one of these is a deuterostome, but is not a chordate? Anagrammata. Right? Protostome. The rest of everyone else is protostome. Because we learned it. We did. Yay? Was that a good question? Awesome. So definitely focus on those, I think. We can talk more about phyla, maybe in the coming days. Another thing that you want to talk about was respiration, right? What does respiration mean? To breathe, right? No? No, it's all biological. The cell level or the... Okay, so I would say cell level is what we were referring to, right? Okay, cool. What organelle should I draw here? I guess probably let's see, that's going to draw a chloroplast. Yeah, that definitely wouldn't work though, would it? So that's a finger, right? What are these infoldings called? Infolding? Cristae. Perfect. And there's like 3 different zones that's occurring here. The outside anaerobic zone of glycolysis. The zone right through here that is the Krebs cycle. And then the zone right through here where I will show you ETC and chemiosmosis. Right? Cool. In glycolysis, what do you start with? Glucose. And you make 2 pyruvates. You make 2 NADHs. And you make 2 of what? And when you make 2 NADHs, you make that through what type of process? That's reduction, right? To make NADH? Whenever you make NADH, you're doing reduction. I want to write that off to the side. If I make NADH, I'm doing reduction. Which means if I break NADH, I'm doing what? Oxidation. Yeah, so it's reversal. Cold beans or hot beans? Get it? Okay. Sorry. The 2 pyruvates go inside. As they do this, they're actually going through this shunt. It's releasing 2 carbon dioxide. It's also producing 2 NADHs. Is that by oxidation or reduction? Reduction. And you're incorporating 2 acetyl-CoAs. Perfect. Do you know how you made these 2 ATPs right here? What type of level phosphorylation? Substrate level. Substrate level phosphorylation at that point. And that's making your, like all these chemicals, your 2 pyruvate though, go inside the mitochondria. They become, if you will, going from this anaerobic medium on the outside. They become aerobic, just like 80 spandex. Get it? Aerobics. No one knows what I'm talking about because y'all weren't alive in the 80s, I guess. At any rate, there's aerobic respiration on the inside, which means purely oxygenation. You form 2 acetyl-CoAs from your 2 pyruvates. The acetyl-CoA is incorporated in the Krebs cycle, and along the way in the Krebs cycle, you're producing a couple of important things: 6 NADHs, 2 FADH2s. Y'all still with me on this? You're also making 2 ATP. What else are you making? How many? Booyah, who said that? Represent. N. Representing. Thank you for representing us. Good? No. How many carbons was glucose at the very, very beginning? 6. You release 2 there, and then you release 4 right here. What is 2 plus 4? 6. There's your 6 carbons. Where are your 6 carbons at? Yeah, they've exited. You've blown them out. You've blown them away. Not, you understand what I'm saying. Question.
Is that when it changes to the other phosphorylation?
Well, this right here is still, this phosphorylation right here is still substrate level phosphorylation. But it's not, it's still substrate level phosphorylation. Now, the deal is that you've released a little bit of energy, but you haven't released like a tremendous amount of energy. So it's time to cash your saved in, right? It's like, I go to work, each day. They pay me like a Coke and a candy bar, basically. And I eat my candy bar, but I save my Coke in my fridge. And then I cash it in, right? So it's time to cash in your winnings. Realize that when you do that, you shunt all the H pluses to the inner membrane space, as I'm drawing here, and you start to carry the electrons through the ETC. There's your ETC, your electron transport chain. So your electrons are carried. And where are they dumped off at? Dumped on O2 to make. Perfect. And when that happens and you make H2O, you're left with all these H's, though, on the outside, right? And you get this H that you see right there in H2O. You get it from this movement of H pluses down this gradient. So right there. What's the name of this enzyme? ATP synthase, right? And that's what generates your ATP. Got it? What do y'all think? Is that good? Fun? No? Katie? She's always so positive. Like a proton. Okay, you say so. So there could be a case of fermentation, which is basically what happens when you didn't wear your 80 spandex. You weren't aerobic, get it? Y'all don't get my jokes, do you? Are they out of date? The exercise shows that we're on like a little video cassette. The people in spandex, you know what I'm talking about? So when you're not aerobic, that's like saying you don't have the spandex going on, and you say anaerobic. What does anaerobic mean? No oxygen at all. And you're going to form one of two things. You're going to form lactate or lactic acid if you're an animal like yourself, or you'll form ethanol if you're like a bacteria. Now remember, this is what they do to continue to remake the NAD+ so they can reuse it. Basically, organisms that are doing fermentation realize that there's a shortage of oxygen, so they are going to undo the NADH formation, remake the NAD+ so at least they can run glycolysis again. But again, glycolysis is a very, very temporary solution. In your body, it's like 10 seconds. Which would explain why, if you're not in good shape at all, you're in 10 to 20 seconds, and it's all over. That is glycolysis, those first 20 seconds. Nope. It takes the pyruvate and makes lactic acid out of it, which is, that lactic acid will be sent off to the liver. It takes your NADHs that you made right here, you see that? And reverses the process so that you can make the NAD+. You reformed the NAD+, so you could redo this process again. So it's this is truly, you do realize that fermentation and lactic acid production is a negatory, right? We've associated that mentally that from gym or whatever it is you do, lactic acid equals sad face. 100% with me? And that is because, one, it hurts, and it's designed to hurt because the lactic acid still has tons of energy in it. It's like you going to McDonald's, buying a 20-piece nugget, eating 2 of them, and throwing 18 away. You're throwing energy in the trash. Or like you going to the gas station, paying for 20 gallons, pumping in like 3 gallons, and putting the other 17 gallons like up in the air. It's like of no purpose, right? It's completely wasteful, agreed? Lactic acid is on that level of waste. Your body does it though, is a quick fix to produce what limited energy it would need. And I'm saying in the process of producing lactic acid, you reform the NAD+ so you could redo glycolysis again. Me? Okay.
What is the first energy that you should bring
if you're going to use like your glucose, your free glucose first, then you're going to use your glycogen next, which is your stored glucose in muscles and brain.
But what is the separate? We like to grow these muscles like phospho, and like you only have like a little bit of it, and also phosphate. I know we could use like respiration.
I mean, you might have like phosphocreatine, phospho. Yeah. You have a lot of phosphos though. It's not just like basically that's enough to saying you have free ATP and free GTP and free CTP and free UTP and free TTP. Like you have all these free triphosphates that are just randomly chilling out your muscles. And I just did this to show off my guns, and that ATP's gone, dude. From this point onward, I'm going to be using respiration. Wait. No, it's back to ATP. Now it's respiration. So you see how like it's that quick turnaround? Yeah. So you use 3 of those. So the order is like the free ATP, and then you're using like your glycogen, and then you're using like your free carbohydrates and glycogen. Then you start to break down protein, and then finally fat. And that takes hours to get to that level of breakdown of fat only. Like you would have to work out like non-stop. I mean, if you ate nothing for 12 to 18 hours, you wouldn't have enough energy really to work out. Living? You start to break down more fats within like 12 hours, but you're still breaking down like tons of more protein than you are fat. You have to go days without eating to start breaking down fat.
And isn't there something that like our red blood cells and like brain cells can't use, or like red blood cells can't use like mitochondria?
Yeah, oxygen.
Oxygen, like what?
Think about it. Remember the example was like, let's say you love donuts, and I sent you to the donut shop. What would be the problem with that? You'd eat them all on the way back.
So, like, what is red blood cells use?
They just do glycolysis. They don't have mitochondria, so they don't use the oxygen that they're carrying around. Like, if I said I want donuts, who would I send? The kid that loves donuts or the kid that hates donuts? Hates donuts. Why? He won't eat them on the way back. If I wanted someone to transport my oxygen around my body, who would I choose? The guy that doesn't use it, right? Red blood cells. Get it? Then you're going to go get them. Another red blood cell you. And you're wearing a red shirt too, so win-win. Question?
So lactic acid is like fixing the liver or whatever?
Yeah, and the kidney as well. Yeah, gluconeogenesis. Yep, absolutely. And that's perfect because it's like, again, the lactic acid is still valuable, it's just like not 100% valuable, but the liver fixes it and remakes glucose so you can retry. I mean, it's, again, seriously, like if you were engineering something, you'd engineer it the same way. So powerful. Yay? Question? Julio? Comments from anybody? Okay. What? What? What'd she say? Was it mean?
No.
Good. Keep it positive. Like those protons over there, Katie. Let's talk about macromolecules, right? Now, we don't have a ton of time. I know on one day, what day is it? Someone help me out. What was the macromolecule day? Because I know I've already talked about it once.